Morning.
Good morning. Hello. Welcome back. Thank you. So we are continuing on our exponential functions. Last time we were together, we discussed this kind of general form. We got to see where in this general form the horizontal asymptote was located. That's K. We got to see whether it was reflecting, so it was going to appear above or below the asymptote. That's A, negative. And then we used the fact that we can turn the exponent into 0 to help us find some really good points all clustered together that generate some fairly simple numbers so that we're not like guessing at random. Okay? So that's what we're going to work on today. Let's go ahead and start at the top of the notes, day 4. That's on the back of your page 3 notes, by the way. We're going to start with the function on the left. Before we graph, we're going to try to answer all of this information before we even draw a single thing. What is the horizontal asymptote? Beautiful, and thank you so much for giving it to me in equation form. Horizontal asymptote is y equals 2. What is the domain for our exponential functions?
Numbers.
All real numbers, exactly correct. Remember, you can write your all real numbers as this funky capital R or in interval notation. Feel free to write it whichever method you like the least. That will give you the most practice, so that way you're fluent in both. What would be the range for this thing?
Oh, I'm doing the wrong one.
Yeah, we're on the back of it, day 4.
Greater than 0.
Is it greater than 2? I mean greater than 1?
Okay, definitely is going to be greater than 1. Here's the easy way to write down the range. Take the equation for the horizontal asymptote and write it without the equal sign. So you have y, space, and then some number. Then we're going to look at, excuse me, the number in the A position, that number out in front. And we're going to look at it and go, is it negative?
No.
It's not negative, so we're going to use a greater than. If it was negative, would be the other way, less than. That's it. That's how you write the range for these guys. Super simple. Classification, is it a growth or is it a decay?
I don't know.
Without graphing. It's a decay. How do you know? Because I see a fraction right here, and this fraction is smaller than 1. Perfect. Good. Let's grab some points so that way we can start to graph it. The first point that is the easiest for us to grab is going to be the value of x that makes that exponent 0. So what I've done is I have taken the exponent and I've set it equal to 0. And then I'm going to solve that one. What does x need to equal? -3, because -3 plus 3 is 0. All right, so if I look at -3, I'm going to come over to my graph. Here's my -3 right here. Okay? That's an exponent of 0. If I move 1 to the right, I'm at x is -2. What exponent would I be at? I went from 0, and I'm moving to the right 1. 1. So when x is -2, my exponent's going to be 1. Take a look at your exponent. Your exponent is x plus 3. If x is -2, this reads -2 plus 3. -2 plus 3 is exactly what we said. Now if I start at 0 and I move to the left 1, what exponent do I expect to be at? -1. And if I move 1 more to the left again, I should be at, and this is a really easy way to not have to try to think, oh, my exponent is going to be what again? No, once you find your 0, you know that 1x to the right is going to be an exponent of 1, and one exponent to the left of whatever value is making your exponent 0 is negative 1. Okay? Makes it a really easy way for you to just generate a bunch of values. So now I can run like this entire series without having to think really hard about things. Because when x is negative 3, my exponent is 0. Because I made it that way. Right?
Yes.
Okay. Anything to the 0 power is 1, so this is 1 plus 2. 1 plus 2 is 3. Now we had just discussed that when x is negative 2, the exponent is 1, so this is 1/3 to the 1 plus 2. Anything to the 1 power is itself, and a whole number plus a fraction can be written that way. When you're graphing, if you're calculating it out and I'm like, show your work, please leave your answers in a fraction. But when you go to graph it, if it's easier for you to graph as decimals, you're welcome to convert those fractions into decimals so that you know where you are in your graph, if you cannot think graphing in fractions. Okay? All right, we discussed that when x was negative 4, our exponent was a negative 1. To undo a negative exponent, take the base, write it as the reciprocal, make the exponent positive, and then continue forward. Again, when you have a negative exponent, write the reciprocal of the base, write the exponent as the positive version of itself, and then continue forward.
What if it's not in fraction?
Okay, so if the base is not a fraction,
It's just
is
not-
the question. Okay, so like this thing. So if I were, say, doing something like this, where my exponent is a negative 1, right? So I'm going to take the reciprocal of the base. The base is 3. The reciprocal of this is 1/3, because we're going to take this little fraction and we're going to flip it. Apply a positive exponent, and then continue forward. Okay, great question. Thank you. All right, now that I have a bunch of points, let's go ahead and start to graph this thing. Start your graph with the asymptote. That'll make your life a little bit easier. My asymptote is y equals 2, so I'm going to come up to my y equals 2 line. Remember, that's a horizontal line. And I'm going to put a dashed or dotted line all across that. It's dotted or dashed. Dashed. It's a dashed line. It's a dashed line because it's not really there. That line doesn't exist on the graph, but I need to be able to see it so I know where the wall is so I don't smack into it with my function. Okay? All right. So when x is 3, y is 3. When x is negative 2, y is 2 and a little bit. So there's my 2 and a little bit. Some fraction. When x is negative 4, y is 5. And when x is negative 5, y is 11. All right. There are my dots. So my graph is going to come like this, swoop around just as neatly and as beautifully as I can. And remember that it's going to go toward the asymptote. It's not going to get close to it. And we're going to use that arrow with just one little thing coming off it so it doesn't look like I'm crashing into the asymptote. There it is. And I'm going to label my function. And I'm done. I would like you to. If they're, I'm going to zoom out a little bit. If my function names are different, you can get away with just writing the function name. If the function names are the same, then you either need to color code and then write the function name so I know, oh, this is the blue f of x and this one is the red f of x. You know what I mean? Or write the entire thing. I'll allow you freedom of choice on that, but
Just kind of like we change it, like, is it like both X or crossing out the?
so if they're both f of x, your question is, can I change the name of this one to like g?
Yeah.
Sure. I'm okay with that. You can change the name of the function. Right on. I guess you're already looking at the homework, huh? And they're all f of x? Yeah. I'm okay with you changing the letters. I'm not going to be offended. All right, let's look at the bottom of the page. There are 6 different items here. I'm happy to do as many of these examples as you want. I would love to do at least one. So as you look at these, tell me which one looks the most intimidating. This one? Yeah? Because we got some big numbers, and there's a fraction with a big number, and oh my lord. Okay. Start with horizontal asymptote.
Y equals negative 73.
Y equals negative 73. Always looking at that last number, always writing it y equals. Nicely done. The domains of exponential functions are always gorgeous, so you get all of this for free. Again, you can write it in either way, this, or you could write it all out like the words all real numbers. That's fine too. Again, use the one that is the least comfortable to you. Okay, so you practice with it. What would be the range?
Y is less than 73.
Okay, good. You identified that it's y and you identified that it's negative 73. And the question is, how do I know whether it's greater than or whether it's less than? Because I heard 2 different responses. Both of those came up, and one of them had a question in your voice. So to decide that greater than or less than, look here. You're going to look right in this space. And you're going to ask yourself, is there a negative? No, not a negative. Make it greater than. If there is a negative, make it less than. Take a moment and write yourself a little note what you need to remember when you're looking at this, so that you know what to do when you see a positive and what to do when you see a negative. And you can write it in words instead of symbols if the symbols are weird. So little eyeballs. They're little eyeballs. They're looking. You're going to look here. Last thing is the classification. Where are you going to look for the classification? At the base. Yeah, at the B, the base right there, the thing in the parentheses. He's saying it's a growth. Do I have any other suggestions? Decay. And the
Because it's less than
fraction less than 1. How do you know that this fraction is less than 1? Because you put in the calculator and it gave you a decimal that was less than 1. If you don't have access to the calculator, and there's a quiz tomorrow and I'm still having the argument, so assume no calculators. How could we tell without a calculator that this fraction is less than 1?
The number on top smaller than the number on bottom.
The number on top smaller than the number on bottom makes the fraction smaller than 1. Top smaller than bottom, smaller than 1.
So that means it's a what? Decay?
That means it's a decay. Oh no.
I wrote all of that
Yeah.
on the one on top.
That's okay. It's all right. You can just.
I can erase it. It's pencil.
Okay. Any other questions? That's it. That's all it is. And, and it's really simple to overthink and make it complicated. Yeah. So.
Absolutely.
Yeah. Yeah. Same. I complicate things way too much. So remind yourself of this acronym, please. I already messed up my acronym. Keep it simple. Silly person. Sweetie, keep it simple, sweetie.
Keep it
Keep it simple. That's all I had for you today. Thanks, guys.
Yay.